Well, good afternoon, everyone. Thank you very much for joining our CPEP seminar today. Happy Earth Day to everyone. So hoping you're finding ways to celebrate and acknowledge that. We have a really nice lineup of speakers today. Hopefully you're taking advantage of lots of the different Nelson Institute and other Institute activities this week across campus. But I'm really pleased to be able to introduce these four folks for our CPEP talk today. I'm going to take a few minutes and introduce all of them right now, and then each one is going to take about 10 or 12 minutes to introduce one specific aspect of their work that they're working on that they'd like to present for us today. So without further ado, I will present them, and I believe this will also be the order that they will present in. Also, just maybe as a note of order, I believe we'll have a little time at the end for questions. So either please hold your questions until the end, or if you want to start accumulating any of those in the chat, that's just fine as well. But maybe we'll hold off on taking any live questions until the very end. So our first speaker is Professor Ankur Desai. He's the Vilas Distinguished Achievement Professor and Department Chair in the Department of Atmospheric and Oceanic Sciences here at UW-Madison. His lab studies and focuses on ecosystems, weather, and climate, and they have authored over 200 journal articles. His work and the group's work spans from Wisconsin to the globe, uses long-term observations in nature and advanced computer simulations. Ankur is also an American Meteorological Society certified consulting meteorologist and a fellow of the American Geophysical Union. Our second speaker is Bridgette Mason. Bridgette is the Assistant State Climatologist for Wisconsin. And in this role, Bridgette supports Wisconsinites by providing the State Climatology Office's three pillars of climate services: information, interpretation, and investigation. Prior to joining the SCO, Bridgette was an agricultural climatologist with the USDA Midwest Climate Hub, a computational scientist with Nutrient Ag Solutions, and a student at the University of Illinois, Urbana-Champaign, studying atmospheric sciences and crop and soil management. Our third speaker is Dominic Holt. Dominic's the coordinator of the Wisconsin Initiative on Climate Change Impacts, WICCI, as many of you know, which is a collaboration between the University of Wisconsin-Madison's Nelson Institute and the Wisconsin Department of Natural Resources, and a stakeholder engagement and policy coordinator with the DNR Bureau of Environmental Analysis and Sustainability. Dominic joined the DNR in 2017 after 14 years in the nonprofit sector in Michigan and in Washington, D.C. and in Wisconsin. And he has over 2 decades of experience in public policy and outreach on a range of priorities at the national and state level. Dominic's also a published poet and writer. Our fourth speaker today is Hannah Zanowski. Hannah's an assistant professor in the Department of Atmospheric and Oceanic Sciences at UW-Madison. Hannah uses and her group uses climate models to do research, which has 3 main focuses: present and future Arctic ocean change, the physical oceanography from periods ranging from 4 to 2.5 billion years ago, and ocean circulation and heat transport on exoplanets. Hannah is also the director of the STORM REU, which I believe she's going to speak about today. This is a National Science Foundation funded undergraduate summer research program spearheaded by the AOS department in conjunction with the Center for Climatic Research, the Space Science and Engineering Center, and the Cooperative Institute for Meteorological Satellite Studies. So thank you again for all being here and agreeing to talk. We are very excited to hear from you. And with that, Ankur, we will turn it over to you.
Okay, thank you very much. Can I just get a quick okay that things look all right?
Looks good.
Okay, thank you, Paul, and thank you everyone for joining on this Tuesday Earth Day afternoon. I'm going to kick this off talking, as Paul mentioned, I like to think about long-term observations and what they tell us about climate. I'm going to talk specifically about the role of what these observations are telling us about solar energy and a particular type of solar installation called agrivoltaics. And so the idea here is, how do we harvest sun for both food and electricity? But when we were all talking earlier, as the speakers, since we're all touching on topics around climate, I was asked to give a little bit of a global context, and I think that's useful for also setting the stage for what I want to do. Here's a lovely view from the NASA EPIC satellite, which sits at one of the Lagrange points of Earth, looking about 1,000,000 miles away, back at Earth. And this is an image not that long ago, but beautiful view of our planet. And when we look at the globe as a whole, what we see is that in last year, my colleagues at NOAA at the Global Monitoring Lab and Earth Systems Research Lab in Boulder take all the CO2 measurements. And what we saw last year in 2024, this is hot off the press from last week, is the fastest increase of CO2 ever. In the modern record since the Industrial Revolution of 3.5 parts per million. So CO2 continues to increase at a rate that is increasing with time. So despite our best efforts at reducing fossil fuel emissions, we see a very interesting feature going on in the atmosphere, which is an increase in atmospheric CO2. Set a record. Not surprisingly, we also saw in parallel, and this is also a recent update from the Berkeley Earth Group, one of the many groups that tries to compile temperature records. 2024 was the warmest year on record in the 20th and into the late 19th century. And part of that was, of course, it was an El Nino year, but partly we also see 2025 up to date in the red with a potential forecast for the end of the year is going to be pretty similar. And so we're continuing to see the globe warm. And we know from many, many different ways, from thousands of studies since the late 19th century onward, that greenhouse gases, what we saw on the first slide, that are driving the increase in CO2, is what drives the increase in temperature. And so this slide here tries to break down that observed temperature increase in black. This is what's reported in the IPCC reports that are produced every 4 or 5 years, to what are the drivers of that? Greenhouse gases, natural causes like the Earth's orbital changes, solar changes, and then aerosols from air quality, air pollution. And what we can see is that greenhouse gases alone actually heat the Earth even more than we observe because of the counterbalancing effect of aerosols. And we know from future continued greenhouse gas emissions, that temperature will increase yet another degree or degree and a half, or maybe even 2 degrees Celsius, to points where Earth will likely have many parts of it that are not safe for humans, not safe for ecosystems, whether for sea level, for heat waves, and for many other things. And most of you have heard all this, but that's where we currently know. The science has not necessarily changed, but we do want to focus a little bit more also on how do we understand how we can resolve this problem, right? And so we have ample solutions to address climate change impacts. So both climate change itself by reducing emissions and also the impacts from current and future climate change. And so, broadly, when I teach classes, we're talking about things like policy and finance, carbon capture and storage, using alternative fuels and energy, sustainable efficient design of homes, industry, transport, and cities, and of course, some of the larger scale solutions like geoengineering or solar radiation management. And so the real question of any of these solutions is how do you get them to scale, to be large enough to actually take a dent on kind of reversing or slowing the rate of climate change and reducing the harms that it causes for people and society and ecosystems? And how do you do it in a way that's fair, right? Equitable, efficient, not overburdening folks who are the most vulnerable to this, for people, for environment, for everything from biodiversity to water services and society. So those are the questions we want to ask. And so I wanted to focus a little bit on solar energy. So why solar? So solar is the fastest growing and cheapest source of electricity globally. And that's been a change over the last decade or so. So here's a graph of solar installation worldwide. You can see last year we've continued to be on an accelerating trend, particularly in China, but even all over the world, approaching almost 10% of the world's energy. In the US, almost half of the majority of new energy generating capacity last year in the US was all solar. And so we're really seeing a large scale shift to solar energy in many, many parts of the world. When we look specifically at the US, that even though it's a smaller blip on the global chart, it's still a pretty fast rising increment in the US as well. One of the things to point out here is that notice that the light orange is small scale solar capacity and the broad dark orange is utility scale. And so there's actually an increase in both of these happening at once. And the challenge in the US is that for any additional new solar development, especially in the Midwest, most of that is going to occur on land that is also currently in use for other reasons, particularly for agriculture. So in the Midwest, agricultural land is our primary option for new solar development. This is an interesting online website I encourage you to look at from the Nature Conservancy called Site Renewables Right, where they actually look at the potential ecosystem impacts on things like whooping crane stopovers or endangered species or wetlands or managed lands. And if you take all of that land out as saying sites that are not necessarily the best options for solar energy or other renewable energy sources, you're left with what you can see all in the gray. And if you know the maps of the Midwest, you know that almost all of that gray is agricultural land. And so that comes into conflict because, of course, we use that agricultural land to grow food. And so the real question we have to ask is it possible to both grow food and generate renewable electricity at the same time? Now, of course, we can talk about some of that land is also being used for ethanol, and that's a different story. But the real questions are, if we could do that, what potential impacts might we be able to see? What benefits do we gain, and what are the ecosystem impacts on everything from water quality and flood control to soil formation to species diversity and pollinators? And so you might think of this as, what if you go from a land use conversion? Here's my colleague Steve Lohide in engineering standing in front of a corn stalk, replacing that with growing some crops underneath or next to solar panels, as shown on the bottom. That's the question that our current project is trying to go to. And this is broadly called the field of agrivoltaics, or the idea of using solar energy by changing the spacing, heights, and locations of solar panels. Could you acquire electricity and grow food at the same time, also providing a secondary income source for many of these farmers and growers? So a few years ago, the UW, through the Research Forward program, funded my lab along with Steve Lohide in civil engineering and Chris Kasharg in the College of Ag and Life Science and Agronomy to study this, particularly at a new site that is being set up. And the idea here of the so-called Kagansa Research Campus Solar was to have a purpose-built research agrivoltaic site. There's not many of these in the world, and so there's lots of agrivoltaic sites, but very few that were purpose-built for research. So this is on UW land next to the Physical Sciences Lab in Stoughton. Sunvest was the company that developed it. Here's kind of a CAD image of the solar panels in the farms. Alliant Energy is generating the energy and selling the energy, and then UW is allowing research to go on this 2 megawatt, 5,000 panel facility. As the facility is just operational this month, and we just started research. But prior to that, we started doing some studies on other sites run by Madison Gas and Electric and other energy companies to understand how things like vegetation and solar and productivity are changing under existing solar sites to be able to better design our study for this new site. So a group, Chris and Steve, study things like leaf area. So here you can imagine taking transects in different locations between the panels, under the panels, to the east and the west of the panels. And leaf area index is a measure of how much leaves are there under the ground. And one of the interesting things you see here is that areas either to the immediate west or certainly between the rows have far more vegetation than areas to the east. And some of that is related to light availability. I had an undergraduate student last year with the laser program, freshman named Liz Garcia, who's coming back to our lab this summer. And she's a computer science student who wanted to get her hands dirty. And so she built this chamber to study CO2 productivity of those same plants. And one of the things we found in her simple site, a very surprising finding, is that it wasn't the open fields that were the most productive. More negative here means more carbon photosynthesis, taking carbon out of the atmosphere. But it was really the partially shaded spots between the panels that were actually taking up the most carbon. And this has some implications for productivity on this land. And we're going to come back next year to do some more studies on this. We also had a class came out last year, my measurements class. That's an undergraduate class of atmospheric science students that looked at microclimate differences. So here, for example, is the difference between temperature underneath and outside the panels and humidity. And one of the things that you see is it's not consistent. So red means places where under the shading is hotter than between the panels. And blue means the opposite. And the same thing here, green on the bottom means areas where humidity is higher underneath the panels, and orange means humidity is lower or drier underneath the panels. And so there's kind of this strong diurnal cycle. And so these have implications for plant growth, water availability, and so on. My colleague Steve also is an eco-hydrologist, so he studies a lot about the water cycle. And one of the things we find is the existence of solar panels, right, changes or tends to reduce evapotranspiration. That tends to then increase water recharge into the groundwater table and increases risk of flooding. And you can see this in this particular study. You can see that underneath the panels had significantly higher water tables throughout the season at this one site. And so all of these studies that we did last summer are helping us design kind of a super site here at the Kagansa that's going to happen this summer, where we have a whole variety of soil plots, water infiltration plots, a variety of continuous monitoring of different vegetation between and near panels to better understand how does agrivoltaics affect the ecosystem and how can it maintain food production and how can we do that optimally. One of the things my lab is doing is specifically bringing out what we call eddy covariance flux towers that allow us to directly measure whole ecosystem exchanges. As far as we know, these will be the world's first flux measurements ever made over solar panels, and partly because it's a very complicated micrometeorological problem. And so my PhD student, Emily Mather, on the top, along with researcher Jonathan Tom, and this undergraduate senior thesis student, Jen Kell from environmental sciences, are kind of helping design this study. And we just put out these towers a few weeks ago. This is raw preliminary data, as ugly as can be. And what we show here are two different towers. The blue is in the solar array and red is in a control field next to the solar array. And you can see, I mean, so basically this is over a week. The negative here means carbon uptake, positive means carbon release. You tend to have release at night, uptake in day. But what you do see is that in the array, the blues are slightly more negative than the reds, which means there's a slightly more carbon uptake going on in the solar array, which is a little bit surprising to me. This is only a week of data. It's only April. It's still pretty muddy out there, so we don't know what this means yet. But this is the type of data we're going to collect over the next couple of years and really start to flesh out what's happening in this system and how the microclimate change, the water cycle change, and a productivity change all feed into the total carbon and water exchanges happening, which contribute to things like the slowing the growth rate of atmospheric CO2 by enhanced carbon sequestration, as we saw in the very first slide. Of course, all of this is reliant on federal and support and funding from a variety of partners and people who are working all around the world. And I would be remiss if I didn't also mention just how much of an emergency we are in right now about the future of the type of research we're doing. We will learn nothing about how to resolve the issues around climate change and what is the benefit of solar and agrivoltaics without dedicated researchers who have spent decades of time and years and sustained support. Currently, the NOAA budget for atmospheric research that includes all of those measurements for CO2 you saw will lose 100% of its funding. Some of my best people have already left because they can't work in this environment anymore. No climate record, no CO2 measurements, no research on the causes of future climate change. Hundreds of researchers being laid off currently, right now. NASA plans a 50% cut. DOE plans a 50% cut if the president's budget passes. There'll be no Earth observing satellites to understand microclimate changes, no climate models, which are primarily produced by the DOE, or research in agrivoltaics, which was broadly funded by the Department of Energy but canceled last month. And our brightest minds are no longer welcome to study in the US, and those who are here are being actively removed without notice, creating a culture of fear. And scientists of minority identities are actively being harassed and accomplishments being disappeared. Most of you are aware of this, but if you're not, you should know that we are in an emergency. This is not a drill. And a culture of fear is set in. History confirms that we are sliding quickly into what we've called a competitive authoritarian regime. And I can send you citations on that. And universities are being targeted for questionable reasons, losing their operational funding to keep the lights on, our ability to recruit students and acquire and use current grants and maintain academic freedom to pursue and teach all ideas freely and fairly. And so if you care about these things in your personal capacity, and I'm sharing with you in my personal capacity, if you care about the people involved, the studies you just saw and the studies you'll hear about for the rest of this hour and the education and outreach we all do, this is the time to act. And I encourage you to think about how you vote, how you share your concerns with legislators, and how you speak up. This is not a slide that I'm very happy about putting into a talk about research that's super awesome and exciting, but I have no choice, and I hope you will understand too. So thank you.
Thank you very much, Ankur. Really appreciate you sharing both about the project and the last slide, which of course is very important as well. So much appreciated. Thank you. Our next speaker is Bridgette, and so we'll pass it over to you, Bridgette.
Thank
And
you.
I can see your slides, so it looks great.
Great. Thank you so much. Thank you for our meeting organizers and Ankur for those very kind and passionate and important words about why we need this funding. Thank you so much for expressing that. And thank you, everyone, for joining us. As Paul said, my name is Bridgette Mason, and I am one of the assistant state climatologists at the Wisconsin State Climatology Office. And I'll be sharing a little bit about who the State Climatology Office is and what we do. And so it is our mission to offer climate services that help Wisconsinites use weather and climate information most effectively. And in practice, the SCO follows our three pillars of climate services, those being information, interpretation, and investigation. So, information means that we provide our users with reliable weather and climate information. And we emphasize reliable because there is a lot of information available online these days. And so, we want to make sure our citizens and our fellow researchers have accurate, trustworthy information they can depend on. Interpretation means that we assist our users in how to understand and apply this information. Weather and climate information can be complex and technical, and so we are always going to be there for you to understand and apply that information in your everyday lives. And lastly, we investigate or we conduct basic and applied research on Wisconsin's climate, and we divide research into the two categories of basic and applied because to us they serve slightly different purposes. So, what we call basic is our curiosity driven general research, and what we call applied is tailored to helping Wisconsinites with decision making. And our team has grown quite a bit over the last 2 years, and we are very excited about that. Our office was entirely volunteer based from the early 2000s until the beginning of 2023. And then at the start of 2023, when funding began, our office had 5 members. And then over the last 2 years, 6 more have joined us. And in addition to our directors and our assistants, we have a communications director, research assistants, a postdoctoral researcher whose research you'll hear about in just a moment. And we've recently added 2 outreach specialists to our team, and I'll talk about their roles in a few minutes as well. So, as I mentioned, our office investigates Wisconsin's climate or does a variety of research. One project that our postdoc is working on is helping prepare Wisconsin's rural communities for amplified weather extremes. And the goal of this project is to improve the capacity of rural Wisconsin to manage extreme weather events. And the focus regions of this project are specifically the driftless area as well as central and northern Wisconsin. And as mentioned, this project is focused on rural communities, and in particular, we're looking at supporting agriculture, schools, and emergency planners. And a big part of this project is hearing directly from communities about the weather extremes they are facing. And some of those weather extremes that they've already expressed concern about are floods, droughts, heat waves, false springs. But I want to say that this list certainly is not exhaustive, and there's certainly more to come as we continue researching. Another topic our office is actively investigating is the question: is Wisconsin becoming snowier? And the short answer is it's complicated, and I'll share with you some of the reasons why it's complicated. So, on the right side of the screen, we have Wisconsin's average seasonal or winter snowfall from the winter of 1891-92 through 2023-24. And just based on these average snowfall observations, we see that the 132-year record shows that statewide snowfall has increased by 12 inches. However, as I mentioned, the answer to this question is a little more complicated than just identifying a trend line in the observations. One reason why it's complicated is because snowfall is measured differently nowadays than in past years. One such way is that the time of measurements has changed. Historically, about prior to the 1950s or so, snowfall was measured infrequently, sometimes once daily, sometimes every hour. Nowadays, the standard practice has shifted to measuring snowfall every 6 hours, which leads me to my next point that nowadays there is more frequent clearing of snow on measuring boards. So, historically, measuring boards or snow boards were not required to submit snowfall reports, but nowadays these boards are the standard practice when measuring and reporting snowfall, and they are cleared every 6 hours. And lastly, prior to the 1950s, snowfall observers would assume that the liquid equivalent of snowfall, meaning how much liquid water is in the snow, was a perfect 10-to-1 ratio, meaning that when 10 inches of snow was melted, it would produce 1 inch of liquid. But scientists and observers learned that most snow does not fall in this perfect ratio, and thus we no longer assume this perfect 10 to 1 snow to liquid ratio. Another reason why answering the question, is Wisconsin becoming snowier, is so complicated is because warming winters can actually produce more or less snowfall. So there's kind of this threshold temperature at which more snow can fall. So warmer air can hold more moisture than colder air can. So, if the air temperature is closer to freezing and even sometimes 1 or 2 degrees above freezing, more snow can actually fall than if temperatures were very, very, very cold. Because again, warmer air can hold more moisture, and thus more snow can fall, which could explain why we have seen such an increase in observed snowfall in Wisconsin. However, thinking about the future of snowfall in Wisconsin, with the warming trend we have seen, particularly in winter, we will eventually cross that threshold temperature or that tipping point, and the precipitation that once fell as snow may eventually fall as rain due to warming temperatures, and thus this trend may not continue for much longer. Now, there are a variety of impacts of snowfall on industries like recreation and tourism, agriculture, snow removal, transportation, and many other industries. Therefore, our office is so dedicated to identifying whether the increasing trend in snowfall in Wisconsin is real or spurious in order to support our stakeholders who heavily rely on snow. One more example of the research or investigation we do on Wisconsin's climate is time below freezing. So, we've anecdotally felt like we've been spending less time below freezing, but our office wanted to try to put some factual data based evidence into answering that question. We've researched the amount of time Wisconsin spends below freezing each month, averaged between 1951 and 2024. And we also researched the trend in time below freezing between 1951 and 2024. And so what we found is that based on the 73-year average, Wisconsin spends about 80 to 100% of its time below freezing in the month of January, and only about 40 to 70% of the time below freezing in March. What we also found is that since 1951, freezing conditions have become less common, especially during March and December. Overall, we've seen about a 1 to 3% decrease per decade in the amount of time spent below freezing between December and March. Like snow, there are a variety of impacts that result from the amount of time we spend below freezing, such as whether we see liquid or frozen precipitation, whether or not snowpack is preserved, and also whether or not ice forms or melts on surfaces. And thus, our office is continuing to investigate the amount of time Wisconsin spends below freezing, as our stakeholders really need to know this information. Now, not only do we do research and investigation on Wisconsin's weather and climate, we also do outreach to provide information and interpretation to Wisconsinites. We do a variety of outreach efforts, and I've listed just a few here, but there are plenty of other ways we are happy to engage with folks. So, for example, we give presentations on various topics and to various groups, including the agriculture industry, gas and electric industries, even architects or master naturalists, master gardeners, and many others. We also do more one on one engagement with the public and students, such as attending farm field days, having booths and interactive activities at functions like the Wisconsin Science Festival. And we are also happy to host groups at our office if that's something you're interested in. We are also closely connected to Wisconsin media and give interviews in a variety of formats, such as written articles for newspapers, video interviews for TV news, podcasts, radios, and other such formats. And we are also active on social media and ensure we share relevant and timely weather and climate information on our social pages. And one final example of the type of outreach we do is answering public inquiries. Nearly every day, we either get an email or a phone call from anyone. It could be anyone in Wisconsin, across the nation, or even across the world, asking for weather and climate related information. And questions can range anywhere from, are we going to have a white Christmas? Or what is the hottest football game played at Lambeau Field? Or what's the relationship between climate change and squirrels? And yes, that last question was really one we received. So we are always very happy to respond to the best of our ability. So please don't hesitate to contact us if you ever have questions or comments or just want to chat about something. And lastly, more times than not, our research and outreach efforts come together to support our stakeholders in decision making and managing their productions and operations. And so I just wanted to share with you a few examples of those more tailored products of information we provide. And one such way is through our climate summaries, which are monthly, seasonal, and annual reports that showcase what happened around the state. We are also involved in the Wisconsin Drought Task Force, which is part of Wisconsin's emergency plan and consists of Wisconsin government representatives and federal representatives. And the SCO contributes to the Drought Task Force by monitoring and reporting current conditions, trends, and forecasts of environmental variables relevant to drought. Because Wisconsin is such an agriculturally productive state, we enjoy providing support for the ag industry. And one way we do so is by co developing an agriculturally tailored report called the Wisconsin Ag Weather Outlook, which is a way to provide farmers, ag advisors, and conservation staff with information and impacts on Wisconsin agriculture based on current and forecasted conditions. We also have attended various tribal sugaring network events to provide the network with weather and climate information that will help maple sap producers make decisions and understand when sap might start flowing. And lastly, we also work very closely with dairy cattle producers and researchers on developing a dairy cattle comfort index, which would be a reference tool to help producers make management decisions around their dairy cattle based on a variety of environmental factors like temp, precip, humidity, cattle age, or whether cattle are in barns or out in the pasture. So that's all from me. I hope you've been able to learn a little bit more about who the State Climatology Office is and what we do. Our team is very passionate about supporting Wisconsinites, so please do not hesitate to reach out at any time and bring your questions with. Thank you so much for your time.
Thank you, Bridget. Really appreciate that. That was a very nice overview of the SCO and the products and the research that's going on there. So thank you so much for sharing. If people online do have questions, again, particularly maybe so far for Bridget and Ankur, feel free to start adding those to the chat, and they might be able to respond to some of those. At this point, though, I definitely want to pass it over to Dominic, and thank you for being here and for presenting as well.
My pleasure, and thank you. There we go.
Looks
Hello.
good.
All right. I'm Dominic Holt with the Wisconsin Department of Natural Resources. I help coordinate WICCI, the Wisconsin Initiative on Climate Change Impacts. Today, I'll provide just a brief introduction to WICCI, Wisconsin's collaborative network assessing climate impacts and fostering solutions. First, as climate change affects nearly everything, so too nearly everything can affect climate change. Therefore, there's no shortage of things we all can do to help, and every little bit adds up. Despite the challenges, we have to remind ourselves that there is hope to make things better, and taking action together is the best way to make that hope a reality. Together, we are finding ways for planet and people to become more resilient to the new normal of weather ping pong or weather whiplash, more unnatural disasters, and a warmer and more uncertain world. A network of networks striving to better understand and better address climate impacts in Wisconsin. The Wisconsin Initiative on Climate Change Impacts is a great place to join the effort. Formed in 2007, WICCI is a partnership between the UW-Madison Nelson Institute for Environmental Studies and the Wisconsin Department of Natural Resources, as you heard earlier. The Nelson Institute and DNR co-sponsor and co-lead WICCI. Our co-directors are Steve Vavris, director of the Wisconsin Climatology Office at UW-Madison Extension, and you just heard a great spiel about that office, and Sean Kennedy, Climate and Resilience Policy Advisor at the Wisconsin Department of Natural Resources. WICCI's mission is to address the climate crisis, and it is a climate crisis, by generating and sharing information to foster solutions to climate change impacts in Wisconsin. WICCI's vision is a climate resilient Wisconsin. To accomplish this mission, WICCI bridges the gap between science and climate practice and policy. We do this through collaboration among a broad interdisciplinary network of participants. WICCI participants include fundamental and applied researchers in academia and beyond, or basic and applied researchers, as mentioned earlier, natural resource managers and other public stewards at tribal, state, county, and local government agencies, other issue experts and practitioners, tribal nation rights holders, stakeholders, and communities. Though it may not be obvious, WICCI's organizational structure is really that of a network of networks. Now, what do I mean by a network of networks? Well, first of all, we have a small leadership and administrative group called the Coordination Team, on which I serve. We also have a working groups council comprised of chair people from each working group, which supports collaboration and innovation among the working groups. We also have an advisory council comprised of stakeholder and rights holder leaders who bring diverse scientific and institutional perspectives to inform the work. And most importantly, the working groups. And this is where we get into the network. Each working group is a network of volunteer participants connected to the networks of those participants, home or organizations or employers, and related partners. Working groups generally identify their own priorities based on the climate needs of their home organizations or employers and their constituents. This is WICCI's grassroots approach to collective action to achieve our vision of a climate resilient Wisconsin. The bulk of the work, or the magic as we like to say, occurs in these thematic focused, volunteer driven working groups. Here they're sorted by the categories of air, water, land, and people. We currently have 14 working groups focused on a vast array of topics. WICCI working groups include agriculture, climate, specifically climate science and data, coastal resilience, community sustainability, especially local governments, fisheries, forestry, geospatial, which actually serves all the working groups. And when we say geospatial, we mean geographic information systems and data, Great Lakes, human health, infrastructure, plants and natural communities, tourism and outdoor recreation, water resources, and wildlife. So you can see we cover quite a range of landscape, if you will, of the adaptation and resilience field. WICCI research and implementation projects focus primarily on climate adaptation and resilience, but that work frequently has co-benefits for climate mitigation as well. WICCI is also increasingly focused on mitigation strategies and solutions in particular. For example, some working groups have been working to identify the best ways of removing carbon from the atmosphere through natural and working lands. Other working groups are examining methods of reducing greenhouse gas emissions, such as those found in construction materials, and best practices for co-locating agriculture and solar panels, known as agrivoltaics, as you saw in Ankur's excellent presentation. Now I'm going to run through some projects and product examples because we have quite a range, as you might expect. And our projects and resources are incredibly helpful to anyone trying to plan for a changing climate. So, I bring your attention first to statewide climate assessment reports. WICCI published the first one in 2011 and then the second one in 2021. And we're beginning to develop an assessment report update that we plan to launch next year in 2026. These assessment reports focus on the newest climate science, climate impacts in Wisconsin, and strategies or solutions for addressing those impacts. All working groups contribute to these statewide reports, and thus they are quite comprehensive. Moving on to working group specific examples, the Climate Working Group routinely develops publicly accessible data and maps, some of which I think you saw in some of the previous slides, previous presentations. They also provide projections on climate impacts in Wisconsin down to increasingly local levels through statistical and dynamic downscaling methods. Working groups are also involved in a variety of site-based demonstration projects, and these are frankly where the rubber meets the road. For example, WICCI participants are part of a climate adaptation project with tribal nations and the Great Lakes Indian Fish and Wildlife Commission to restore wild rice on Spur Lake. Also known as manumin, or food that grows on the water, wild rice is very vulnerable to climate change, and it's incredibly important culturally and as a healthy food staple for tribal nations. In another example, the Plants and Natural Communities Working Group has been participating in over 1,000 acres of climate adaptation work at Rush Creek State Natural Area. Now, this is along the Mississippi River, and it's been going on for over 3 years. The Natural Resources Foundation of Wisconsin and Wisconsin Department of Natural Resources both lead this effort, and it's the first grassland adaptation project in the state. This project is creating vital refuge for a variety of species attempting to cope with our changing climate. On a webinar in February, actually, partners released a short film highlighting this project. There's a link to the film. I won't show it here today, but we will share with you the slides so you can get to that. Here are a few more examples of working group studies, publications, tools, and related resources. The Coastal Resilience Working Group has been working with Green Bay communities to better understand and report on climate research needs for that area. The Community Sustainability Working Group has been exploring the potential impacts of human climate migration on local governments in the state, because various resources seem to think that Wisconsin might be a quote-unquote Goldilocks zone when it comes to perhaps having less climate impacts than other parts of the country. The Community Sustainability Working Group also published the results of its 2022 Community Sustainability Survey. The Tourism and Outdoor Recreation Working Group recently launched a story map on climate change's impacts to recreational opportunities unique to each region of the state. The Infrastructure Working Group has developed a guide on flood-resilient road stream crossings, which is crucial if you've heard at all about the blowups of basically roads and highways and whatnot throughout the state, and surveyed Wisconsin public infrastructure managers, planners, elected officials, and consultants about how they're managing infrastructure amidst the climate impacts they're experiencing. Also, the Fisheries Working Group is developing and testing decision-making frameworks with communities to better manage walleye threatened by warming waters. And not just that, this working group and many others publish in academic journals frequently. The Human Health Working Group developed a case study article on how Wisconsin's Heat Vulnerability Index identifies Wisconsinites most at risk of dangerous heat due to climate change. And the Forest Working Group has developed a series of short bulletins on timely matters, such as forest carbon, invasive species, prescribed fire, and more. And I could go on, but I won't. So let's collaborate. Here is my email address and phone number, as well as the WICCI website, which is wicci.wisc.edu. Big thanks to the Nelson Institute for hosting and managing that excellent website. Please reach out to learn about joining a working group, to request a speaker for an event, or discuss other collaborations. On the website, you can sign up for the WICCI newsletter. You can find stories about climate change impacts and projects in communities around the state. You can discover science-based tools, fact sheets, reports, guides, data, and more. And you can even donate to support the work. And of course, find WICCI on Facebook and LinkedIn. Now, I just want to follow up some of the other very important messages shared today. Climate change is happening here, and we know this, and it's daunting, but there is much we can do together, and we must, for everyone's sake, now and in the future. Even in the bleakest of times, there is hope. And that's important when it comes to climate change, because often climate change can completely devastate people, but there is hope whenever there is a community of people who care and are willing to act. That's why the Wisconsin Initiative on Climate Change Impacts is here, and so many of these other wonderful colleagues. So please get involved. Thank you so much.
Well, thank you, Dominic. We really appreciate that. Very nice overview of WICCI and the many products and activities and projects that are going on through WICCI. So thank you for giving us that overview. Really appreciate that a lot. And then our fourth speaker today is Hannah. And Hannah, looks like I can see your screen just fine. So we'll turn it over to you. Thank you.
Okay, thank you all. I will close us out here. We've got... okay, I'll see what I can do and still leave hopefully some time for questions. All right, so today I am going to talk to you about the Storm REU. If you do not know what an REU is or any of these acronyms are, don't worry, by the end of this talk you will. All right, so let's dive into things. So if you don't know, an REU is actually a National Science Foundation funded program. It's called Research Experiences for Undergraduates. It's all about getting undergraduates involved in research over the summer. It's actually been a program that's been around since 1987. I just looked this up recently. It's so nearly 40 years at this point in time. And they were kind of built or developed just because early on, NSF actually had a mandate to diversify the STEM workforce, right? So, and then RUs are again just one way in which the National Science Foundation hoped to achieve that. Had question mark given some of the more recent developments with this current administration. I will come back to that later. All right, so it's all about getting undergrads involved in research. And so we actually have one of these programs here within our department. So this is my program that I spearheaded actually with my fearless co-PI Ankur Desai, who's also on this call. Our research experience for undergraduate program is called STORM. It stands for Student Training in Oceanography, Remote Sensing, and Meteorology. All right, and so those are things that are traditionally been our department's strengths, at least for the last like 30-ish years or so. Less oceanography prior to that, right, when the department was mostly atmospheric science. So what we do is we bring 10 students out each year for 3 successive summers for 10 weeks to do research with faculty in the Atmospheric and Oceanic Sciences Department, research scientists in the Cooperative Institute for Meteorological Satellite Studies or the Space Science and Engineering Center here in the building, as well as folks from the Center for Climatic Research, right? So it's a collaboration across all 4 of those programs. And then students come out to do research with faculty or research scientist mentors. It's really kind of a sort of overall program, though, where you're not just learning how to do research and going through the research process. It's also about kind of giving students professional development opportunities, other activities to kind of get them involved and exposed to this process. It's a paid internship. We also provide housing, you know, all sorts of things like that. So they come here, they live on campus, they come see us every day during the week, do research, and learn all about what it's like to do that. So our projects basically go anything from aerosol impacts on Midwest storms, tropical atmospheric dynamics, agrivoltaics, like Ankur mentioned, all the way out to Arctic oceanography, which is what I tend to focus on in my research. When this program's been around for 2 years now officially as an NSF-funded REU. Prior to that, it was built out of a pilot program that I ran the very first summer that I was here, trying to see if we could bring students out, get them involved in research, could we feasibly do this at a slightly larger scale. So since this program started in 2023, one of the major things that we wanted to do was actually recruit students from historically excluded groups with a particular focus on minority serving institutions. The goals of the program ostensibly are exposure, enrichment, and empowerment. All right, so that's kind of what we have here on the little logo that our amazing graduate students built out for this program. It's basically to provide undergraduate students with this first or near first experience in STEM research, particularly in atmospheric and oceanic sciences, to promote development of a set of research, self-reflection, and interpersonal skills that are going to serve them throughout their career in science, as well as to empower them to sort of approach science and be a part of science as they are, not as somebody might expect them to be, right? So to kind of get into the program, like I said, we've had 2 official classes so far. These are those classes of students, in addition to a couple of extra students who kind of come along for the ride, who we just adopt into the REU if they're doing research here in the building in the summer. We are actually taking a break this summer, so the 3rd year of the program is going to run in summer of 2026 instead. So we do a ton of stuff in the summer. So these are just all pictures of some of the many things that we've been doing. So we, like I said, in addition to each student being paired with a research mentor, we have weekly professional development seminars that cover anything from learning how to write computer code in languages like Python, how to build a CV or resume, networking, presentation skills. So whether that's oral or poster presentations, we kind of have a weekly seminar about that where either I lead that or graduate students lead it, or other faculty or other scientists kind of are out and about throughout campus. So they're kind of getting this additional information basically just about how to do, not just how to do science, but how to be a scientist, right? And in addition to that, this is something that's kind of more special in our program, is that we also focus on some of these more personal development skills, like talking about our mental health, self-advocacy, actually developing your scientific identity, things that, we tend to not think too hard about, but actually are really fundamentally important to overall well-being, which helps us do our science, right? And so I meet weekly with all of the students as a group as well, just to kind of check in, see how they're doing, see if there's any problems. And then also there are weekly department and cohort activities where students get to either go out on field trips, like we take them to the National Weather Service in the Milwaukee Sullivan office for a day. We do a rooftop weather balloon launch, which, maybe you can see over here in some of these pictures. We've got an end of summer poster session where they present their work with a separate RU on campus, which is freshwater at UW. We have a lot of team building exercises like the mentor-mentee game afternoon, which is that picture in the upper right corner where the mentors and the students all get together and we play games. And so there's a picture there of a group of us playing giant Uno together. And so this is a way for students to kind of get to know us, get to know the department and the program, and feel just comfortable interacting with us in a way that's not just strictly about science and that way of thinking about needing to do things, right? So it's get to know each other in that way as well. All right. And so I will say that, these programs really do work. They really are very helpful for students. And so this is just a figure from one of the survey questions we asked our students at the end of the summer is basically, what kind of skills do you think you actually gained or improved upon during this program, right? So every time we come out, we have a bunch of ways in which we try to evaluate our program. And some of this is through student self-reporting. We have other methods as well. And in general, students really do note improvements across hard and soft skills by the end of the summer. So this plot is just a bunch of list of different skills there on that y-axis, and then the number of students who reported some sort of improvement in that, right? It is variable, right? Of course, if you're me and you're a perfectionist, you want all those to be 10 out of 10, but that's absurd. And so the goal here is that every time we do this, maybe things can change a little bit, get a little bit better in regard to that. It also helps us give us an idea of what things, students might wanted to have learned, but we didn't necessarily provide that learning opportunity for them, right? This also depends on where students are when they come in. Some of them might have a little bit of prior research experience or exploration with this. So an additional experience maybe doesn't necessarily lead to the same, level of improvement for one person rather than another, right? So again, across the board, things are kind of really improving. And then beyond this, they also have a lot of written testimony, which I'm not going to put up here, but they note things like increased likelihood of attending grad school, better understanding of the research process overall, like new lifelong friendships that they've developed by being with their cohort throughout the summer. So again, a lot of different pieces of this that happen within this program, right? So there are some lessons I think that I've learned in the couple years that I've been doing this, and in the hope that we'll be able to continue this program in the future, right? You really kind of need to be in it to win it. If you want to run an RU that actually achieves its stated goals and doesn't harm the participants, it's a ton of work. All right, like a lot. You really need to put your heart and soul into this, as well as a whole lot of your time. Okay. And related to that is that it takes a real village of people to do this. You need buy-in from your entire department, other programs that are helping you out. And it is absolutely not possible without dedicated graduate students, staff, mentors, and leadership to build out a program like this and see it off the ground. And I really want to highlight our graduate students in particular, who have done a huge amount of the legwork for this particular program to be where it is today. So thank you to those of you who have been a part of this, because I really appreciate it. Communicating expectations, everyone involved needs to be on the same page and know what their role is in the program. Otherwise, it's the Wild West, and honestly, it often is anyway. So that's something that I've been learning, is how do I make sure that all the things that are rattling around in my head actually get told to the right people so they can go and do their part in the process. Last piece, shit happens. A good program is a flexible program. Things are never going to go as planned, almost ever. For example, mentor-mentee pairings aren't always going to be perfect. Maybe, things don't work out super well. You're going to have to navigate conflict, accept feedback, kind of dealing with all of those pieces, right? So we've learned a lot just in the few years that we've run this, but again, this is an iterative process. And so I see it continuing to change over time as we grow and build this out. And the last thing I just want to say, though, is that, in the current administration, in the current, uncertainties with funding from the National Science Foundation, the future of RUs is becoming more uncertain. This was an article that came out in Science earlier this semester. So in the end of February, when we were dealing with those potential freezes at NSF, there were actually downsizing to the summer RU programs that NSF funded. And so Some of them were potentially cut. Some of them just, they had to cancel their program for the summer because they're still waiting to hear back whether or not they're going to continue to be funded or not. So it's caused a lot of issue, right? And then this plus the impact on our side for the affirmative action decision with the Supreme Court was also a potential roadblock for REU recruitment and admission, at least in terms of UW-Madison. But again, I will say that these programs are deeply impactful. For example, we have 2 students, one from each of the classes that are actually now in our graduate program. And just today, I got an email from a student who was in our program last year because they wrote to us to tell us that they got into the Noah Hollings program. And they wrote specifically to thank all of the mentors within our program who deeply helped them be a part of that. And they really mentioned that they wouldn't be there without our guidance, right? And so these programs just really have a long-term positive impacts on students, recruitment and retention, especially of historically excluded students in graduate school and for their STEM careers, all right? And so I think what I want to say here is, the last thing I want to say here is my biggest takeaway is really don't lose sight of what matters, right? We're facing an onslaught right now of anti sort of DEI things within this administration, outside of that, right? But we really need to keep programs like this around, all right? So arguments that DEI actually harms the people traditionally in power are honestly total bullshit. And they actually ignore the wealth of research and direct evidence that says otherwise, right? And so no matter what happens, I think we really need to make sure that these stay around because it does matter who does science, okay? So I choose to create a world where everyone who wants to do science actually can do science. And this is why I do this program, all right? I choose our planet. And I choose the benefit of everyone over the benefit of the few, okay? And so that's really what I want to focus on and why these programs are so important. And you know what? At this point in time, you're either with me or you're not. So I'll leave it there. Thank you.
Thank you very much, Hannah. Really appreciate that very much. That was a very nice overview of the REU program, one of them at UW-Madison. Thank you for your efforts in leading that and keeping that going, and exciting that there will be another summer 2026 with that as well. Thank you to all of our speakers. This was really, really a nice set of talks and an overview from a wide range. And so I do want to say thank you. We have a few minutes left. So if there are, it looks like there's not been, at least to me, or in the general chat, much activity in the chat. If there are questions from the audience, please feel free to put those in the chat. Or if anyone would like to offer up a verbal question as well, we do have a couple moments for that before we wrap up. So I'll wait a minute to see if there are any of those. Sophia, please ask your question. Thank you.
Hello. As I'm an undergraduate student here, interested in the environmental sciences, do you each have any advice for those who are starting their careers in this space in light of the amount of uncertainty at this moment?
I can jump in if everyone's okay with that. Keep going, Sophia. Don't quit. Just, no matter how uncertain it is, we're still here, and we're still here for you to help you in that process. So if you're thinking like you're interested in this, you're interested in getting in research, reach out to potential faculty or researchers who you might like to work with. We love talking about ourselves and our work. So if you're like, hey, can I just talk to you about what you're doing? That's a good way to potentially get started. Also, just leverage people that you know me now, and you know that I run programs like this that you might be interested in doing, not necessarily ours, but maybe elsewhere. We can have a conversation about that if you want to. But the biggest thing is no matter what, and no matter how uncertain it is, uncertain things are, we still need people like you to be able to continue this into the future, right? So stay on board, even if it looks really grim. right? We're not going to get better by having none of us do this. We have to stick together.
Thank you.
I love what Hannah said, and Sophia, I'm a recent grad as well, and I just want to echo what Hannah said about networking and talking with people who might be in fields that you might be interested in. I've learned so much the value of just having those connections. So like Hannah said, you know all of us now. You've heard from all of us. Don't hesitate to reach out at any time. I just want to echo that point especially.
Thank you, Sophia, for your question, and thanks, Bridget and Hannah, for fielding that. Well, we are running up against time, but if there's one more question, I'll be happy to entertain that. Well, if not, then let me again thank you thanks to our four speakers. It's the virtual applause is always a little bit of an awkward one, but thank you very much appreciated. Thanks for sharing, and happy Earth Day, everyone. And I hope you can find ways to celebrate that and honor that. So enjoy the rest of your day. And for those regular CPEP attendees, we have one more yet this semester, so next Tuesday, and that one will be again live and back in person and online as always. So thank you very much. Enjoy your day and happy Earth Day.
Thank you.
Thanks, Paul.
Thank you.